Ever wonder how big companies seem to know what's coming? How they just, predict demand or figure out pricing with this crazy accuracy? Well, it's not a crystal ball. Nope, it's a really powerful statistical tool, and today we are going to break down exactly how it works.
So, yeah, how do they do it? It's honestly one of the biggest questions in business. And predicting what's next isn't just a cool party trick. It's literally the key to survival. We're going to tackle this like a detective story, uncovering the clues that data leaves behind to figure out what's around the corner.
All right, first up, let's talk about the why. Before we get into the nitty-gritty of the tools, we've got to understand why predicting the future is so much more valuable than just looking at the past. This is where our investigation really kicks off.
I mean, knowing what happened last quarter, sure, that's useful. But the real power, the game changer, is making a really smart guess about what's going to happen next quarter. Businesses need to forecast everything: future revenue, customer demand, costs. Success really hinges on how good those predictions are.
And this is our main tool for the job: regression analysis. It's one of the most popular and powerful ways to do what's called predictive analysis. The core idea is actually pretty simple. It's a technique to figure out the relationship between different things. It basically answers the question, if I tweak this one thing over here, how is it going to affect that other thing over there? It's the mathematical engine that powers prediction.
So let's make this super concrete. Imagine a company sees that, hey, every time we pump more money into our ad budget, sales go up. Well, regression analysis can take all that past data and build a model that says, okay, based on history, if you spend X amount on ads next month, we predict you're going to make Y in sales. It turns a simple observation into a forecasting powerhouse.
But, and this is a big but, here comes the plot twist in our little detective story. Just because you found a pattern in your old data doesn't automatically mean you've built a reliable forecasting tool. Oh no, it's a little more complicated than that.
And this right here is the absolute crucial point. Anybody can draw a line through a chart of past results and shout, "Look, a trend!" But a model that looks perfect on old data can be completely useless, or honestly, even dangerously misleading when you try to use it to predict the future. And that is the million-dollar question, isn't it? How do you make sure your model has actually learned the real pattern, like a good detective, instead of just memorizing the tiny details of past events? A model that only memorized the past is going to be totally stumped by anything new. So how do the pros avoid this trap? Well, they use a very specific, very clever method to build and test their models, just to make sure they're actually ready for the real world. And the solution is, believe it or not, surprisingly simple. You hold back. You don't let your model see all the data at once. You keep a piece of it totally secret to use as a pop quiz later on. Here's how it works. You split your data into two piles. The training data, that's like the textbook and the homework problems you give the model so it can learn. Then you have the testing data. This is the final exam. The model has never ever seen these questions before, so how it performs here tells you how well it'll actually do out in the wild. Okay, so our model has taken the final exam. Now what? Well, now we have to grade it. And we can't just give it a thumbs up and say it did pretty well. No, for a real investigation, we need an objective score. We need to evaluate the evidence properly. To do that, analysts use what are called evaluation metrics. Think of them as standardized tests that score the model's performance on that data it's never seen before. They give us a hard number so we can judge just how good our model's predictions really are. Let's quickly break down the big three. First, you've got R-squared. Think of this as the model's confidence score. A number close to 1 means your model explains a lot of what's going on in the data. A low score means it's missing some key clues. Next up is MAE, or mean absolute error. This one's simple. On average, how far off are your predictions? Are you off by $10 or 10,000? Lower is always better. And finally, there's RMSE, root mean squared error. It's a lot like MAE, but it's a really tough grader. It punishes big mistakes way more harshly. So if your MAE is low but your RMSE is high, that's a red flag that your model is making a few really bad predictions. But our investigation isn't over just because we have a score. A true data detective looks deeper. They don't just care if the prediction was right or wrong, they look for patterns inside the errors themselves. To do this, we use something called a residual. It sounds a little technical, but it's the final and maybe most important clue in our whole investigation. It's simply the error from a single prediction. The math is just basic subtraction. What did your model guess versus what actually happened? That difference is the residual. A positive residual means you guessed too high, and a negative one means you guessed too low, Simple as that.
And here's the crucial part. In a good model, these errors, these residuals, they should be totally random, just all over the place, no rhyme or reason. But if your model's errors are predictable, that means your model is missing something really important. It has a blind spot.
For example, let's say your model is always too low when predicting sales during the holidays. That's a systematic pattern. It's a giant red flag screaming that the model doesn't understand the idea of a holiday shopping rush. You're missing a key ingredient in your analysis.
So, let's wrap this investigation up. Regression? An incredibly powerful tool for seeing into the future. But just building the model is only step one. You absolutely have to validate it with unseen testing data. You have to score its performance with objective metrics. And most importantly, you have to analyze the pattern of its mistakes to uncover its hidden flaws.
See, this isn't magic. It's a serious process of building, testing, and refining. And now you know the exact steps the pros take to create a forecast they can actually rely on. So the final question is, looking at your own work or your own life, what hidden patterns could you uncover?